Hey guys, Brett Kelly here, 45 Drives, and today I'm going to show you exactly how to build a highly available, high performance, low cost, and easy to set up storage cluster. I'm going to do this out of our Storinator S45 storage pods, some WD enterprise drives, and the wonderful open source tools ZFS on Linux and GlusterFS. Now to help speed the whole process, like I said, easy to set up, we have created a tool set to really speed along the whole process from building Z pools all the way up to starting your Samba shares. So why don't you join me on a screen cap and we'll show you how to get this done. Okay, so let's get started. I've got two terminals open here, Gluster 1 and Gluster 2. These are my two Storinator S45 storage pods. I'm just going to open up a text document I have here, and it's just kind of the steps of the setup so you can watch along as it. But mainly what I'm here to do today is I'm going to take my two nodes that I've already set up, networking and operating system and all that fun stuff, install all the packages. I'm going to take these two nodes, I'm going to build a replicated cluster between the two of them. I'm going to share it out via cluster sharing CTDB, a Samba share, and I'm going to join it to an active domain Windows computer. So these are the general outline steps here, and I'm using 45 Drive Storinator storage pods and the tool set that we created around this to just kind of ease the process of building, assigning drive aliases, building Z pools, building your Gluster volumes, sharing it out so you can spin up new storage clusters in a matter of not that much time at all. I was going to say seconds, but that's a bit of an exaggeration. So I guess we'll follow along to the left here. The nodes I'm using is Gluster 1, and I've already assigned an IP to them, and I've made a network bond, and I've got it in the balance ALB mode. That's recommended by the Gluster guys. It can speed up the write performance of your Gluster volume. Long story short, GlusterFS replication replicates client side as of 3.8 version, I believe. So all writes are half of the available bandwidth when using a replica too. But using balance ALB, you're able to write to the servers a bit faster, and I've seen peak around 750, 800. So bonding. So I set it up in a balance ALB. So I already set up networking. It's out of the scope of what I'm doing here. Then I've already opened certain firewall ports that I'm going to need. We've got a little firewall cheat sheet we'll just flash later or now. So let's get into it. I've got my two nodes, and step one is drive aliasing. So remember, we're gonna build a Z pool, we're gonna build Gluster volume, then we're gonna share it out. But step one, you've got a bunch of disks in this system, and how do you address them all? How do you build a pool? So traditionally, you may be experienced with just clean this up a bit, your traditional SD names, so like dev, SD, whatever, and this is how most people, I don't like the look of that, most people could build a pool using these. But the problem with these names is they are not reliable. They're convenient, but they're not reliable. If you pull one of them, plug it back in, it's not getting its old name back, it's getting next in the line. So you can't trust that. You can't locate drives based on that. So your next best bet would be dev disk by path. By path is convenient because it tells you the exact physical location of where that disk is. So this is your card ID, this is the slot. Based on a map, you can figure out exactly where that drive is. Problem is, so it's this long path. Oh geez, no, sorry. It's this long path plus this name. That's not very fun to write out, especially when you have upwards of 45 or more disks in a system. So luckily, the people behind ZFS on Linux wrote some custom Linux UDEV rules that allow you to assign easily human-readable drive aliases to each drive. So you can get the best of both worlds. You can get a name that you can assign to a physical slot on your 45 drive server, but it's as convenient as the SD name. It's just really easy to remember and use. So setting that up is as easy as making a config file, but we wrote some tools to speed the process along. So dmap and it'll ask you which disk controller, and I'm using an R750 in this case. And chassis size, I've got a 45, so an R750. And it spits out this. This is the config file you could write out by hand, but the nice thing about ours is it'll just do it for you automatically. And so I'll just do the other one on this real quick. It's C R750 S45, and I'll just be quiet. I'm gonna ask again. Gotta fix that. So you may be well and good. What does that mean? What can I do with that? Okay, LSDev is a quick little tool we got here. And I don't like the coloring scheme on that, but these darker ones are not in the system, and the light blue ones are drives that are in the system. So this is the physical layout. That's all well and good, but so this is how you can address your disks now, by the slot name that it has. This is directly tied to what's printed on the silk screen of the server itself. Okay, so by creating the drive aliases, I get the best of both worlds. I get to easily refer to the disk by an easily human-readable name, but I can trust that it's reliable, and the drive labeled 1-2 will always be in slot 1-2. And another great part of that is, no matter if you're physically at the server or you're remotely at the server, the disk is named the same thing. That's great. You don't have to worry about serial numbers or any of that fun stuff anymore. So now that we made the drive aliases, we can get to work because we've named our drives, and we don't have to worry about the tedious battle of screwing with 36 long names. So the next step is we're going to make our ZFS pool. So I have 36 drives in my pool, or I've got more in one of the servers, but my common denominator is 36. So I'm just going to use 36 for this example. There's 6 terabyte WDRE drives. I'm going to build a 4 by RAID Z2 VDEVs of 9 drives each. And what that is instead of making one big Z pool or one big RAID volume of RAID 2 parity, I'm going to make essentially 4 and then split them up. Or sorry, not split them up, stripe them. So I get the space of all of them, but I get the redundancy. I get extra redundancy and some extra speed. There's a lot of benefits, but I'm not going to go in right now. But that's the Z pool I'm going to build. So we made drive aliases, which are a lot easier to use, but if you're going to write out the command, you still have to write out 60 names, or 45 or 30, or how many disks you have, and that can be annoying. So we made a tool that will just take some basic input. I'm going to say, give me 40 VDEVs, and only use 36 disks, and it'll take a guess at what I wanted to build, based on what it can find in the system. And by default, if you run it without the -B flag, it'll just spit out what it's going to build. So you can just double check. Yep, that's what I need. Oh, no, I want my A shift value, so I'm going to put that in too. And the reason I use the A shift value is with the sector size of these drives and my parity configuration, I can save a significant, I'd say about 3 or 4 terabytes worth of space with an A shift of 9. And I'll just run the same thing down here. So as you can see, this one finished. It applied some Z-Pool tunables. So I turned off access times, XATR is set to SA. Exec is off, sync is disabled, compression LZ4. Most of these are because I'm building a Gluster volume out of this. Helps speed up access times when using LS and stuff. GlusterFS does its own synchronous stuff, so we can just turn that off with Z-Pool. And compression is just use compression with CFS. It's great. You barely notice it, and it saves you some space. Okay, so that built on both. Let me prove it. CFS list. So I got 147 terabytes I can use. It's mounted at Z-Pool, and we're time to move on. So the next is we have to cut out the bricks that we're going to build the Gluster volume out of. I'm going to build a replicated volume, so I need an even number of bricks on each server. So I'll just do the basic 2 for now. So I'm going to build 2 bricks for a storage volume, and then I'm going to build 1 brick for a CTDB volume, and I'll touch on that why I have to, what that's for when I go to build the Gluster volume. So to do this, we made another script. Really what we're going to do is we're going to build ZFS datasets. But we're going to run make brick, and it's going to tell me which pool I have in the system. and I want you to use ZPool. Okay, how many data bricks? I want to use 2 data bricks. And are you creating an arbiter? In this case, no. Yeah, drop a comment if you want to see more about that. But in this case, I'm not going to do it right now. CTDB volume, yes, we're going to use that. Overt engine, no, we're not going to use that right now. So, and then I go ahead, it makes my bricks. I'll do the same on this one. ZPool, 2, no, yes, and no. Okay, so you may be wondering, 66 times 2 does not equal 147. So this is this 90% quota we impose. So ZFS recommends that you use a certain, well, you don't go over a certain amount of your pool. We set it for 90 here. It can be adjusted. We've seen as low as 80, and we've seen as high as 96. Work fine. So, just to show you, 66 times 2, about 147. There's where we get our 90% from. So that can be changed if you want it to be, but that's where we get our numbers. So these these are what we're going to build our Gluster volume out, and this is what we'll build our CTD volume out. So that's our bricks. So we'll move on to the Gluster volume creation. We'll build our Gluster volume first. We're going to name this tank. It's going to be a replica 2. We're going to make it a linked list configuration. Now, a linked list is the benefits of a linked list is you can add an extra node one by one rather than in pairs. So that's awesome. However, the addition process is a bit easier, as in you have to break a tie, attach a new brick, and let things rebalance. This is in contrast to your traditional kind of replicated volume where you have a pair of 2, and then you have another pair of 2, and you have another pair of 2, and then files get distributed across them. Okay, so our main storage volume is going to be a linked list volume. Now to build this, we're going to use a tool we created called gcreate, but first we have to define a config file that it's going to use. What the config file is it's literally the Gluster command that you could run to build the volume. gcreate will take that, build your volume, start your services, open firewalls, and leave you with a ready-to-go mountable Gluster volume. So I've already predefined this one, but what we're saying Gluster, build me a volume called tank, make it a replica 2, take the first server, its first brick, tie that to the second server's brick 2, take the second server, its first brick, tie that to the first server's brick 2, and then force it. So I'm going to run gcreate, I'm going to say 2 bricks, the other nodes that are participating, Gluster2, and the config file I just mentioned. And I hit enter, give it a second. This is the only step in the process that you can do on just one of the nodes. You build it on Gluster1, it'll be there on Gluster2. So there we go. It was a successful start. Oh, see, I cheated already. I have some of the firewalls enabled. That's what that error was. So there's our information. Brick 1 and brick 2, they're a pair. Yep, and then these 2 are a pair. So that's our tank volume, and now we want to build the CTDB volume. You may be wondering, why do you need 2 volumes? So if we're going to have clustered sharing, there needs to be a shared lock file between the servers, because it needs to know who's got files open at certain times. So the best way to do that, make a pure replica 2 volume and put your CTDB lock file on that. It works the same way. I've already predefined a CTDB configuration file. This is the volume we want to create. It's a simple replica 2. I'm just going to type server 1 CTDB to server 2 CTDB brick. So it's the same command. So I'll just mouse up CTDB. This time I'm only opening 1 brick. So let's try that again. And it'll probably yell at me about the firewall again, because again, I cheated. They were already open. And there it started my CTDB. There's our prayer. Oh look, these ones weren't open. Okay, so now I have 2 Gluster volumes. So let's look at them. Vol status. So here's our CTDB volume. There's its 2 bricks. It's online. Each has got a PID. And here's my tank volume. It's got its 4 bricks, its ports, it's online, all that great stuff. Okay, so now I have my Gluster volumes. It's time to share it out. Okay, with my volume tank created that I want to share out, and then with my I can't say that word, CTDB volume that will allow the service to run, I can go ahead and start configuring CTDB, and then I can configure the Samba share. I can start all the services, and I'll be able to reach it from my Windows computer. Long story short, we do not have to mount the Gluster volume, the tank volume we're going to use, on the nodes themselves. There is a ZFS plugin that we use for Samba that is able to speak directly to the volume on the kernel level, rather than have to mounting in the user space and then sharing it back out. It's much more efficient, speed's better, failover's better. Great way to do that. So I'll show you when we get down to the Samba setup how to do that. So first, what we have to do is we have to mount our CTDB volume, GlusterFS. We'll use the GlusterFS fuse mount. We're going to mount it localhost. Actually, you know what? I've already got an entry in fstab. Vim and so this has to be permanently mounted at all times, because CTDB needs to know where the lock file is, so it can know that all your files are not getting overwritten and corrupted. If this is not mounted, CTDB will not start, and your Samba share will be unavailable. So let's make sure it's mounted. Mount CTDB. Mount CTDB. Okay. So we made a script. I have to go to long name. This has to be done on both nodes, by the way. We made a script that will CTDB has a couple configuration files you have to generate and put in the right locations on each node. So we just made a script that it'll ask you a few questions and you answer and it just does all that automatically. So let's hit yes. So CTDB manages Samba, NFS, or both. In my case, I'm only using SMB. WinBind? Yeah, so I'm using WinBind because I'm using Active Directory. A little side note there, these two nodes have already been joined to Active Directory. So node 0 IP. What's my first node? My first node is Gluster1, 16.4. And you just have to tell it what IP. And this is so CTDB knows which nodes it's working off of. Okay, now VIP address. A very important address. Now, it's the virtual IP. This is the IP that you designate that your share can be accessed from. Now, since CTB kind of acts as the middle layer to handle failover, it presents a virtual IP that the user can connect from, so it's always the same no matter which server is serving it behind the scenes. So in my case, I have chosen that I want it to be 192.168.16.16. What subnet? I want it on my 16-bit subnet. And then you need to choose an interface that it'll be shared out of. So in my case, I'm going to share it out bond 1. So I've got my node traffic and my public and my user traffic on the same interface. It's possible to split them into two, but in my case, this will get the job done. So do I want to enter another VIP? No, I don't in this case. But there's a way you can add multiple VIPs, define them in a DNS server, and you can achieve a little bit of load balancing. But again, for the point of this example, don't need to go into that. So now my CTDB files are where they need to be. I have to do the same thing on the other servers. gtools bin CTDB config, and I'm going to answer the same questions very quickly. Yes. Be careful that I don't screw anything up here. 4, 5, 16, I like the number 16 obviously. Bondo, and no. Okay, so I've configured Samba. Or sorry, not Samba, I've configured CTDB. So I can start the service now, and CTDB will start, but I will have no Samba file, so I will have no share. Okay, we're about 1.5 steps away from mounting our newly made Gluster volume onto our Windows 7 client. I'm just going to have to define a Samba config file, start the CTB service that we just configured, and then assign some permissions, and then I'll be able to mount. So for simplicity's sake, I've already defined a Samba file. So I'm just going to copy that to where it needs to be. Samba. Just copy it again. SMB conf etsy samba SMB conf. Oh shoot. Nope. There we go. And then we can run test parm on both servers just to make sure we're getting what we want. Okay, so everything's okay. So my file is correct. But what we'll talk about real quick is you can see I've got 2 shares here. And I'm using the VFS method of sharing a GlusterFS. So what this means is I don't have to mount the volume on the system and then share it back out. I can just tell Samba to talk directly to the Gluster volume. The really interesting part, well, the really important part to note here is this path. It is not relative to the root of the file system of the server. It is relative to the root files or the root of the Gluster volume. So with this, I have my 2 shares. I want to share storage and I want to share lab. Technically, these don't exist right now. I have to mount my Gluster volume, GlusterFS, local host, tank, mount, tank. Take a second. CD mount tank. And so will ls. See, there's nothing there. So if I started the Samba share, I wouldn't be able to connect because it's trying to share a path that I haven't created yet. So I'm going to make that dir, make lab, and make storage. Okay. And now with that, I can start CTDB. And by starting CTDB, we're telling it to manage Samba, so it'll go ahead and start and stop Samba as it needs it. So system control start. And we'll drop into watch-1n CTDB status. So this will be unhealthy for a bit until it goes healthy. So bear with me as we wait. Okay, there goes the first one, there goes the second one. Okay, so now it's ready to go. That means we can ping the VIP that we started, 16.16. Here we go, we're getting access. CTB IP. So there, node 0 is hosting it. So Gluster 2 is node 1. Gluster 1 is node 0, so Gluster 1 is the master right now. You can see if we restart CTDB, take a sec. We'll go back to the watch. You'll see one of them goes unhealthy. And now look at this. 1 is now the host. So CTDB has designated that Gluster 2 is now the master server. So with that configured, we would be ready to mount, but we just have to fix our permissions. So here's my just regular users in the system, and these are all my Active Directory groups that I've pre-configured and joined all in. So in our Samba file, we mentioned who the valid users were. So these valid users can get onto the share, but unless we give them permission to the underlying volume, they cannot write to it. So they could they'll be able to actively connect to it, but they will not have write or read permission. So right away, this is because root is the total owner of all things, and we don't want that. So let me just open test parm over here so I know what I want. Test parm. Okay, so lab. Who am I saying can read and write to lab? The admin can, so that's the root. I've already created mapping there. I want the group lab. So if anyone's in the group lab, they can read and write to that. So we're going to change the owner, -big R, to root. We'll keep him as the top level owner. Lab. And then we're going to chmod 775 -recursively, even though nothing's there yet. Now look at the permissions. So the root is now still the owner of that file, but the group lab is the group owner. The group has proper read, write, execute permissions. So if I mounted the lab, if my Active Directory user is in the group lab, it can write to that share now. So we'll just do the other thing. We'll just do the same thing to storage now. But as you can see with storage, the answer is domain users. We want domain users. So I'm going to put quotations around it. Domain users. Storage. And yep, that's what I want. And same permissions that way. So there we go. So now we can hop over to my Windows computer here. Open that up. Let's go computer, map a network drive, my server, the VIP, and then the share. And then we'll wait for a second. And there we go, we've joined. So let's make sure my permissions worked. Folder, yeah, I can write to it. So there we go. We now have usable storage. So let's mount the other one, just to make sure that all worked. 168.16.16 storage. And it's there too. Let's double check our write permissions. Wonderful. Now we've got our two shares. 132 terabytes of replicated storage. Just for the fun of it, let's run a speed test real quick. I've got this thing on a 1 gig network. Let's see if we can get line speed. C drive. Well, we won't do the C drive because that's... And as you can see, I got pretty much line speed, which is always fun to see. If you put this thing on a 10 gig line, you'd get 1.1 gig reads, and you'd get probably about 600, 700 writes, because remember, this is replicated. And with a replicated cluster volume, your writes are about half of your maximum network bandwidth, unless using balance ALB, and sometimes you can get a bit more out of it. Alright, well, to sum up, there we go. We've got our replicated cluster volume mounted. We've got 132 terabytes of highly available storage with another layer of wonderful ZFS protection underneath. We walked through how to conveniently address your disks for reliability and efficient maintenance. We built a Z pool for optimized security and speed. We cut the bricks out and applied quotas so we don't unknowingly hurt ourselves in the future. We built the cluster volume out of those bricks. We configured CTDB on each node. We set up Samba. We started CTB so it could cluster and share Samba out, and then we connected to it from our client. So yeah, with 45 drive storage pods, the tool set we created, and the great work of the ZFS on Linux people, the GlusterFS people, the wonderful world of open source software, we're able to create a highly resilient, low cost, high performance, easy to set up really, clustering solution. And if you have any questions, comments, anything at all, please drop them in the box below, and we'd be happy to answer them.